Today we'll learn how to expand ln 1 plus x into an infinite series using Maclaurin's theorem. Let's start by defining our function. We let f of x equal ln of 1 plus x. Then we need to find the derivatives and evaluate them at x equals 0. First, let's evaluate f of 0. When x is 0, we get ln of 1, which equals 0. This will be our first term. Now, let's find the first derivative. The derivative of ln of 1 plus x is 1 over 1 plus x. When we evaluate this at x equals 0, we get 1. For the second derivative, we differentiate again to get negative 1 over 1 plus x squared. At x equals 0, this gives us negative 1. The third derivative gives us 2 over 1 plus x cubed, which equals 2 at x equals 0. And the fourth derivative is negative 6 over 1 plus x to the fourth power, which gives us negative 6 at x equals 0. Now, let's recall Maclaurin's theorem. It states that we can write f of x as an infinite series using these derivatives evaluated at 0. Let's substitute our values. We get 0 plus x times 1 plus x squared over 2 factorial times negative 1 plus x cubed over 3 factorial times 2 plus x to the fourth over 4 factorial times negative 6, and so on. Simplifying this, we get our final result. ln of 1 plus x equals x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4 plus a. This series converges for x between negative 1 and 1. Let's visualize how this series approximates ln 1 plus x. The red curve shows the actual ln 1 plus x function, and the blue curves show our series approximations as we add more terms.